So using the most advanced diesel technology does deliver some pretty significant benefits. So let me focus a little bit more on the ag sector. I know that's one that you're particularly interested in. And we've already covered a number of the different aspects of diesel's role in the ag sector, and they're, I think, probably very much pretty aligned between our two countries. Not only in producing the food stocks and the harvesting and planting of the crops, but transporting of the product, pumping of the water that's needed, and throughout the entire supply chain, diesel has a key role, whether it's moving the grain from the farm elevator to the grain storage facility, to the rail yard, to the inland waterway barge, and so on, and then ultimately to grocery stores around the country. So, the role of diesel in all this is very deeply intertwined. And, the diversity of applications using diesel is quite tremendous. All shapes and sizes, doing all kinds of work. And you're all familiar with many of these, and I'm sure you have some unique ones of your own. But from things that harvest very delicate crops, like tomatoes or strawberries, to some of the row crops and grains, to ensilage, this is the work that diesel does every day. And so one of the things I like to even just level set everyone about, why are we talking about diesel? Why is this, that diesel is the dominant technology that it is today? And it's really for these reasons on this slide, which is this unique combination of features that insofar no other technology has been able to match. We've got a fuel with very high energy density, engines that deliver very high power density from burning that fuel, and they do it quite efficiently. They can operate for a long amount of time or travel a long distance before they need to be refueled. They have high degree of reliability and can last quite a long time. And sometimes the lasting a long time is, can be to our detriment in some ways. It also has a very available, established, and widespread parts, service, and fueling network. And this becomes very important as we start to think about diesel in the context of competing with some of the future technologies like electrification or hydrogen, for example. Diesel is a technology that's also, as we said, achieved near zero emissions. And the last point here is the one we're going to spend the rest of the time on, but that is the suitability of this technology to use renewable bio-based fuels is substantial. And so if we just look at the off-road sector for a second, you can see on the right-hand side here, this is a graph of showing how that sector of off-road equipment, and these are the larger machines that have achieved near zero emissions, effective since 2014, now almost a decade. And just to put that in perspective, it would take 23 of today's diesel backhoes or kind of a medium-sized row crop tractor to equal the emissions of a single backhoe sold in 1997. So you start to get the sense that, wow, the technology has really changed over time, and that is exactly right. Now, turning to that future, though, we all are understanding that some new fuels and technologies are emerging. And in particular for the ag sector, we know that diesel is the prevalent fuel today, but in the future, that's likely to change to some extent. And what are customers requiring in the ag space today? The same things that they've always required, which is I have to have fuel to do my work. I have to have fuel that's affordable. I have to have a way to run my machines and equipment to do my business, whether it's planting crops or harvesting, whatever it might be. So there's a whole range of requirements customers have and will continue to have in the future. But manufacturers and many of our members envision that some of these technologies or tractors and equipment that have relied on diesel in the past will start to see some diversification of fuel in the future. And from top to bottom here, you sort of get the sense of which ones are going to be the biggest players in that space. And the top couple that are getting a lot of traction here in the US are the renewable and biodiesel fuels, ethanol, of course, from the ag sector, biomethane and natural gas and renewable natural gas are emerging much more. And then there's some others that come in maybe more towards the bottom. But diesel, you can see, continues to exist in the future, even alongside of all these other fuels and technologies. And so that is, how do we make the diesel engine better? And we know how we're doing that in the engine, but what about the fuel? The diesel fuel has not changed in the US since 2006, when ultra-low sulfur diesel was first introduced. So I think there's a tremendous opportunity on the fuel side here that we haven't fully realized yet. And the last two are ones that are more current of interest maybe. One is that the use of biodiesel and renewable diesel is increasingly viewed as an alternative for different users, for fleets, for farmers, for others who might decide that they would prefer a different kind of option other than being pushed towards electric or hydrogen or something that they may not be comfortable with, or frankly is not really available at scale or for what they need. So it is an alternative that they can begin doing something towards decarbonizing their sector. The last thing here, and the most recent one in present day, is using more biofuels mitigates the higher diesel fuel prices we're all experiencing because of some of the issues evolving out of the Ukraine, the war with Russia. So part of that is driving up energy prices, and diesel fuel is top of the list there. We're seeing diesel fuel here in the U.S. at over $5 per gallon. It's the highest we've seen on record. So it's got a significant motivating factor there. So one of the solutions to that is to use more renewable fuels if you can. So these are the main motivating factors for getting folks towards renewable fuels. The feedstocks, and I'll get into this a little bit more in a minute, but the feedstocks principally are animal fats and vegetable oils. These are the same. The processing is different. And that's where the divergence takes place between what is traditional biodiesel on the bottom, which results in the fatty acid methyl ester, the FAME kind of fuel that we talk about, or the renewable hydrocarbon diesel that is depicted on the top line, which is a non-esterified renewable diesel product. It's a very paraffinic kind of fuel and is what we consider to be a drop-in replacement, if you will, for conventional petroleum diesel in the US. And it has grown quite substantially over time. You get the sense that we've had some pretty rapid growth in production of biofuels in the US market in recent years. So the opportunity to produce more is seems entirely consistent with where we've been coming from. So to focus on renewable diesel for a second, this is a slide from Neste, which is one of our member companies and is a leader in a global leader in producing advanced renewable biofuels like Neste's My Renewable Diesel. And you get a sense of just from the visual here that it's a fuel that's much more, has a higher level of purity in terms of contaminants that exist. It has very high cetane level, that very favorable ignition properties for both new and existing diesel engines. And it is not biodiesel. And so just to make that clarification you saw from the previous slide, it offers some advantages over biodiesel in terms of stability and longer term storage and some other properties when burned in some kinds of diesel engines. And one of the things that we like to think about when we see comparisons of carbon reduction, we look at California. On the left here, this shows you where their CO2 reductions have come from over the last 8 or 9 years. And some people immediately think, oh, California, all those electric cars must be reducing greenhouse gas emissions. That's where the benefits are coming from. We just need more electric cars to reduce CO2. Not exactly the case. In fact, most of the CO2 reduction is coming from biodiesel and renewable diesel fuel, and then ethanol as well. So you get the sense that if we're interested in reducing carbon on a near-term basis, these fuels and technology have tremendous power to do that and are available as well. And this next slide shows you the specific profile of renewable diesel, which looks even a whole lot better on a wells-to-wheels basis than any of the others that you see there today. Even better than B20 and the basic soybean produced biodiesel. So the waste residues and products have a high degree of efficiency and are converted to useful fuel in ways that some of these other potential fuels are not. So this gives you just a sense of the combustion of these two different fuel types. And the Neste renewable diesel, you get the sense that it burns more cleanly. It is, as I said before, a drop-in replacement fuel for conventional diesel. What you're seeing on the right there is actually the California grade diesel fuel, the CARB diesel. One thing that we're trying to talk about a lot more in the US as we see a lot of advancements and pushes for other policies is the time value of carbon. And so that is, what's the value of removing carbon today versus waiting for a full electrified power sector that's got the ability to charge heavy duty trucks, et cetera, in 15 or 20 years from now. The use of renewable fuels can have some immediate impact, and getting more carbon out of the atmosphere now paves the way to continue to achieve some of those more bold objectives that we have for meeting the Paris Climate Accords, et cetera, in the future. So if we really care about removing carbon from the climate today, the way to do that is to use some more of these advanced low carbon renewable fuels. But I think we have to be realistic that are a lot of pressure for other kinds of fuels and technologies. We see a lot of interest in compact electric construction equipment, for example, and that seems like a really good application. Same thing for last mile delivery vans in urban areas. Great applications for all electric, limited range, lightweight loads, come back every night. That makes a lot of sense. If we're talking about long distance, heavy power demands over extended periods of time, will any of these alternative fuels be able to meet or match what diesel can do? It remains to be seen, honestly. So we do think that the future is likely to be more eclectic than electric. And so I think that's okay. We're going to find that these fuels are going to find their way into the right sectors for them. And so just to kind of wrap up here, diesel is going to continue to play key roles in main sectors of the economy. Changes to the transportation paradigm and clean energy, it's going to take longer probably and cost more than we project. There's going to be some bumps along the way. And the users, there's still a lot of aversion to risk out there, particularly right now. So using advanced renewable fuels that take advantage of what they already have makes managing that risk perhaps a lot easier. And we think that the advantage of renewable biodiesel and renewable diesel fuel is you've got all the equipment that you need that can start using that fuel tomorrow. You don't have to invest in new infrastructure. You don't have to buy a new engine or vehicle or equipment type. So it's really a tremendous advantage there.